Greetings, doctor. My name is PHONG with matrix number 24006013. Today, I would like to present about the application of clamper in a medical device. For your information, we are from Group 1. This is the overall content that we will discuss throughout this video. Welcome to the introduction. Electronics play a vital role in modern medical devices, enabling accurate monitoring, diagnosis, and treatment of various health conditions. From imaging systems like MRI and CT scanners to wearable sensors and implantable devices, electronics ensure the precise signal processing and reliable operation. Among the essential circuits used for this purpose are clamper circuits, which adjust the DC level of an input signal without changing its shape. These circuits are crucial for maintaining voltage stability, protecting sensitive components, and ensuring safe, accurate biosignal acquisition in medical equipment. What is a clamper circuit? A clamper circuit is an electronic circuit designed to shift the entire voltage level of an AC waveform either upward or downward without altering its shape. It achieves this by adding or subtracting a DC level to the input signal using a combination of a diode, capacitor, and resistor. The main types of the clamper circuits are positive clampers, which shift the waveform upward so that it lies entirely above the zero voltage level, and negative clampers which shift the waveform downward below the zero level. In both cases, the capacitor charges during one half cycle of the input signal and then maintains this charge to offset the signal during the next half cycle. These circuits are commonly used in signal processing applications such as TV receivers, communication systems, and analog circuits where restoring or adjusting the DC level of a signal is necessary without distorting its shape. For your information, in medical devices, clamper circuits play a crucial role in ensuring accurate and safe operation, particularly in systems that handle biosignals such as ECG, EEG, and EMG. These biological signals are typically low in amplitude and high sensitive to noise and voltage shift. Clamper circuits help in signal conditioning by adjusting the DC level of these signals, ensuring that they remain within the optimal input range of analog to digital converters or amplifiers without altering the waveform shape. This improves signal clarity and reliability, which is essential for accurate diagnostics. Additionally, clampers contribute to voltage stability, protecting delicate medical electronics from sudden shifts or transients that could result in errors or damage. From a safety perspective, they have prevent unwanted voltage level from reaching patient contact circuits, ensuring that devices operate within safe voltage limits. Overall, clamper circuits enhance signal fidelity, device protection, and patient safety, making them indispensable in modern medical instrumentation.
Good morning, Dr. Tam. My name is Leong. Today, my teammate and I are going to discuss about the application of clamper in medical devices such as defibrillator, MRI machine, and also ECG machine. And now, I'm going to explain how the clamper circuit works in the ECG machine. Let's start with the definition of ECG. An ECG is a simple and painless test that checks the electrical activity of a heart of a patient. The electrodes are placed on the skin to record the heartbeats. It also helps doctors to find the problems like irregular heartbeats, heart attacks, or electrolyte issue. By looking to its components, we can find that ECG consists of electrodes, leads, amplifier, filters, analog to digital converter, which is ADC, display monitor, recording system, and also power supply. Also, there are three types of ECG, which are resting ECG, exercise ECG, and also the ambulatory ECG. By referring to this image, it clearly shows a typical ECG waveform, also known as the PQRST complex. The P wave represents the atrial depolarization, while the QRS complex represents the ventricular depolarization. Besides, the T wave also represents the ventricular repolarization, and the PR interval indicates the time for the electrical signal to travel from atria to ventricles. Moreover, the ST segment represents the time for full contraction of the ventricles. Meanwhile, the QT interval includes both contraction and recovery of the ventricles. So basically, when we look at the circuit overview of the clamper circuit in the ECG, we can find that there are 5 main components that play a role in clamp the signal in the ECG, which are diode, power source, capacitor, voltage regulator, and also the voltage meter. Alright, now let's proceed to the function of clamper circuit in the ECG machine. So we know that ECG machine, it can detect very low amplitude biosignals, typically in the milliwatt range, and it requires precise conditioning to ensure the accurate analysis. Thus, in this case, clamper circuit play a very important role by shifting the ECG signal to a suitable DC level without distorting its waveform, and it allows for effective amplification without clipping. This DC level adjustment is crucial for the ECG to keep the signal within the dynamic range of amplifiers and analog to digital converters (ADCs) to enable the accurate capture of all ECG components such as the P wave, QRS complex, and the T wave. Additionally, the clamper circuits also help to stabilize the signal baseline, reducing the low frequency noise and baseline wonder caused by the factors like respiration, muscle movement, and variation in the electrode impedance. Lastly, I will end my presentation slide by discussing about the future improvement. The future improvement in clamper circuits for ECG machine may focus on the enhancing its adaptability, efficiency, and also the signal accuracy. So the adaptive clamper circuits could dynamically adjust the clamping levels in real time to handle the patient movement and baseline drift more effectively. The low power compact designs using CMOS or MEMS technology would also support wearable and portable ECG device. The integration with digital signal processing, which is also known as DSP, can also combine an analog clamping with digital baseline correction for improved accuracy. Besides that, enhancing the noise immunity through the advanced filtering and shielding can also further reduce interference. In addition, incorporating AI-assisted signal optimization could also allow the system to learn and adjust to patient-specific variations such as the motion, artifacts, and electrode impedance changes to ensure the more reliable ECG recordings. That's all for my presentation. Thank you.
Hi doctor, my name is Zhang Yuan. Today I will talk about the application of clamper circuits in MRI. So let's start. Let's begin with a brief introduction to the MRI. Nowadays, the MRI has become a common medical device with a non-invasive imaging technique used in hospitals. It uses strong magnetic fields and radio waves to produce detailed images of the internal organs and soft tissues of the human body. And it is also convenient for some people who can't use other types of scanners such as the CT scanner or the X-ray. And the clamper circuit also plays an important role in MRI. Here are the three types of the clampers, and the bidirectional clamper are used in MRI system. Let's take a close look at how signal processing works in MRI. So the receiving coils inside the MRI machine detect very weak AC signals from our body. This signal must be sent to amplifiers and analog to digital converters for further processing. However, if these signals are too weak or contain unwanted DC offsets or spikes, they can cause distortion or even damage to sensitive electronic components. So we can see the picture here. At the beginning, the vibration of the red line are so intense, and we can see it spike clearly. But after we add the clamper circuit, we can see that the spike disappear, and the red line become stable. So that means our clamper circuit works. And we can also use an analogy that imagine trying to listen to a soft whisper through loudspeakers without any adjustment. The sound must be very noisy or even damage the speakers. So that's why signal conditioning is very essential, and also why the clamper circuits are so important in MRI system. Then we will take a look at the role of clamper circuits in MRI. So we can see the left of the picture is a circuit in MRI system. We can see the BJT, the diode, or also the clamper circuit and the clipper circuits. It is so complicated. So to be easy, we're just analyzing a small module, small part of the module, and we can see the right of the picture here. It is a very classic clamper circuit. So it serves two proposed in MRI signal conditioning, and one proposed is DC level shifting. So in some devices such as the ADCS, as I mentioned before, can only handle positive voltage inputs. So if the MRI signal swings between negative and positive values, it needs to be shifted. For example, from negative 1 volt to positive 1 volt up to 0 volt to positive 2 volt, so that the entire signal stays within a safe and readable range. And the second proposed is the voltage clamping. So even though MRI signals are weak, they can occasionally contain sharp spikes or noise due to electromagnetic interference. So the clamper circuits can limit these voltage peaks to protect downstream amplifiers and converters from damage or overload. In conclusion, the clamper circuits, though small in size, play a crucial role in ensuring the reliability and safety of high-performance medical image equipment. By regulating the voltage level and protecting sensitive analog circuits, clampers contribute to accurate diagnostics and long-term device stability. And we can also improve the accuracy by conditioning the signals, clamper circuits, so that we can enhance our accuracy of MRI imaging.
Good day, my name is ZHEN, and today I'm going to present the application in defibrillator. So let's move on. So now you guys may ask, what is a defibrillator? So now I will answer for you. So a defibrillator is a medical device used to restore the normal heartbeat by delivering an electric shock to the heart. So basically it was used for the sudden cardiac arrest, which is the SCA, and this case where the heart stops beating effectively and caused by the ventricular defibrillation and also the ventricular tachycardia. So these electric shocks will help to reset the heart's rhythm and allowing to resume a regular rhythm back. So there are several types of the defibrillators, which is the automated external defibrillator AED, the implantable cardioverter defibrillator ICD, and also the variable defibrillator and manual defibrillator. So now let's see the circuit of the defibrillator. So basically in the defibrillator, it has the step-up transformer, diodes, capacitor, inductor, and switch. And the components of the diodes and capacitor makes the circuit of the defibrillator as a clamper circuit. Alright, so next we look for the function of the defibrillators. So what are the functions of them? Firstly, it can restore the normal heart rhythm. The primary function of the defibrillator is to deliver the electric shock to the heart so that it can stop the abnormal and life-threatening rhythms such as the ventricular fibrillation and also the ventricular tachycardia. It can allow the heart to resume back to a normal rhythm. And secondly, it can treat the sudden cardiac arrest, SCA. So basically, the defibrillators are very critical in the emergency situations to revive the person who has a heart stop beating effectively and increase their chance of survival. So thirdly, it can monitor the heart activity in some types, such as the implantable and variable defibrillators. They can continuously monitor the heart rhythm and automatically deliver an electric shock to the patient's heart when needed. So fourthly, it can prevent the future cardiac arrest in ICDs. So the device, the implantable cardioverter defibrillators ICDs, can help to prevent sudden cardiac death by detecting and correcting the abnormal rhythms before the symptoms become fatal. And lastly, the defibrillator can provide the safety instructions, which is especially in the AEDs, which is the automated external defibrillators. The AEDs will guide the users through the voice prompts and the visual cases with the clues, and it can ensure the safetiness and the effective use by the non-medical personnel. So anyone can use it, and it can increase the chance of the survival of the patient. So just now you guys has known about the function of the defibrillator, and now let's move on to the clampers integrate with the defibrillator. So in a defibrillator, the clampers are the electronic circuits used to limit or shift the voltage level within the device internal circuit. So what are the functions of the clampers in the defibrillator? There are four main functions. Firstly, it will limit the voltage. Secondly, it will signal shaping. Thirdly, it will protect the component. And fourthly, lastly, it can ensure the safety of the patient. And now we are talking about the improvement of the defibrillators. So, as we know, the defibrillator consists of the clamper circuits. As such, if we want to improve the functionality of the defibrillator, we should integrate the circuits into more types, such as clampers, clippers, and also some types of the semiconductors such as diodes. So, what are the improvements that can be done? Firstly, we can have a smaller and a more portable design, especially for the people that has a demand for the portability. Secondly, we have a faster charging and energy delivery. As such, less energy will be wasted and we can optimize the energy usage. Thirdly, the smart detection algorithms can be applied, at which the defibrillators can be powered by AI, and the AI will analyze the data from the patient so that the defibrillator may do the correct option for the conditions. Yeah. And fourthly, we can use the wireless monitoring and connectivity. As such, the people can connect their health data towards the health institutions such as the clinics and also the hospitals to let them monitor their health condition by Wi-Fi or cloud technologies. And lastly, we have the integration with the wearable tech such as the wearable watch. As such, the usage of the defibrillator will be more convenient and more easier, and it can be used by more people in the community. Yeah, that's all from me. Thank you.
In modern medical technology, precision and safety are critical, and that's where clamper circuits come in. These simple electronic circuits play a vital role in ensuring that medical device operates smoothly and accurately. Let's look at some of the key benefits of clampers in medical device. First of all, signal clarity. Clampers shift the voltage level of an AC signal without changing its shape. This ensures that signals stay within the correct range, which is essential for clear and consistent interpretation, especially in sensitive equipment like ECG or EEG machines. Second, protection. Medical devices often deal with tiny and sensitive signals. Clampers help protect internal components from harmful voltage spikes or sudden negative voltage that could cause malfunction or permanent damage. This is particularly important in life-saving equipment such as defibrillators. Next, accuracy. In devices that monitor bioelectrical signals, maintaining signal accuracy is crucial. Clampers preserve the original shape of signal while shifting its level, helping doctors get precise, reliable data for diagnosis and treatment. Finally, safety. By controlling voltage levels, clampers ensures that both patients and healthcare providers are protected from potential electrical hazards. This adds a critical layer of safety in clinical environment. In summary, clampers may be small, but they make a big difference, delivering clarity, protection, accuracy, and safety in operation of advanced medical device. In conclusion, clamper circuits may seem simple, but they play a crucial role in the performance of modern medical devices. By shifting the DC level of an AC signal without altering its shape, clampers ensure that sensitive electronic systems function reliably and accurately. From ECG machines to defibrillators and advanced medical imaging equipment like MRI and CT scanners, clampers are essential components that support the safe and effective operation of healthcare technology. They help maintain signal integrity for precise diagnostics, protect delicate components from damaging voltage levels, and enhance both safety and reliability in clinical settings. Ultimately, clampers contribute to the delivery of safe, accurate, and dependable patient care, making them an indispensable part of modern medical electronics.